how well calibrated were the models? Because doing modeling versus ASHRAE rules, right, for comparison percentage savings versus calibrated to actual utility data, it's a different exercise. So
all good questions. The reference isn't on here. I will get you the report, okay, which has a lot of that stuff in it. Actually, if you go to NREL's website and just Google zero energy assessment, you'll find it, okay? But in general, what we find out in the field is that big buildings to little buildings, the energy use intensity doesn't change that much. Yes, and I'm going to explain a little bit why these were small buildings. In fact, the other thing that you notice about these are nonprofits. Right? The leaders in this area tends to be nonprofits. And part of it is that nonprofits tend to have as much money as they want. Because if they need it, they go out and raise more capital. Right? In fact, Oberlin's an interesting story. They wanted to be a zero energy building bad.
they want to be a net energy exporter.
They wanted to be, that's absolutely right. And so they hired an architect, they built the building. I want to say it was somewhere around $500 a square foot. Okay, so kind of pricey, especially.
A lot of it got donated.
But what happened was is that they could pick up the phone, so they didn't make their goal, right? We went in and started monitoring. They weren't a zero energy building. What they do? They picked up the phone and found another 100 kilowatts of PV, added it to the building. Problem solved.
No, near the building.
Near the building. Thank you. It's in the parking lot next door. See, maybe you guys should be doing this, right? Right. That's one way to solve it, right? Put a bigger hammer on it. And there's a lot, each of these has a technical report. If you want to kind of dive into what's there and what the data was doing and some of the things that we learned about those, each of those has its own report, and there's a summary report about all of them. But on those buildings, there were some common themes, right? They all had committed owners, right? They all had aggressive energy goals. It was not tacked on at the end. They all used computer simulation at some point in the design. It is interesting to me that the building industry is one of the largest single industries in the U.S. And for the most part, okay, don't jump out of your seat too far, it is a non-engineered product when it comes to an integrated system. And if we built a car the same way as we build buildings, would it ever leave the parking lot? No. Each one had some successes. Of course, each one had some problems. Many of those problems were similar. A lot of it had to do with early generation daylight and getting the daylighting to work. Daylighting doesn't work unless you get the lights off, or at least substantially dimmed. Right? How many buildings, and I love seeing pictures, you know, look in all the nice magazines, right? Okay, architects, right? All these beautiful buildings, all beautifully daylight. All the lights are on, right? You know, so you can photograph it. Well, it's the wrong image. It's the wrong impression. So there's where some of those technical reports are. Anyhow, there are the URLs for those. We will PDF these and get them out.
So are you saying that CAD/CAM is not used in the buildings as much as it could be? I thought that was
the energy piece of it is not engineered from a design decision point of view. Okay. When was the last time? Designer?
No.
No.
A good general business guy.
General business guy. When was the last time the energy modeler was hired before the architect to determine the form of the building that would make sense from an energy point of view?
I don't know.
Doesn't happen a lot.
Doesn't happen a lot. We're going to talk about why. You might have to stick around for the afternoon to get the full story. Okay?
That's a good.
Well, you got to stick around for the afternoon. All right? Anyhow, one of the things that the assessment taught us this is kind of one of these things where we did an expensive government study. You know, it's this intuitive that, you know, it doesn't take a whole lot of effort. Where are my warehouses on here? Regular warehouses. Right here. All right? All I need on a warehouse is 6% energy savings, 50% of the roof area to make that a zero energy building. Right? A lot of roof area, not a lot of loads. Right? What about, where's my healthcare here? Healthcare inpatient. Right? That starts to look like, you know, this building probably has a bunch of labs in it, right? Right? We need to get a 91% energy savings on the average healthcare facility, cover the roof 50% in order to get that to a zero energy building. Right? Probably not going to happen. Right? Now the good news is, go back to that little thermometer slide, is when I aggregate them together, what are we going to do with all the excess energy from the warehouse? We're going to move it to the healthcare sector. Okay? And so aggregated together as communities, we can start talking about zero energy communities. Okay? But in general, we need a 60 to 70% savings. So starting to hear a theme here, right? The maximum potential we saw in the first one. And one thing about that study was it didn't try to optimize those. It just had to apply a set of rules and send them out, right? So 50, 60, 70% savings is where we need to be to even start talking about zero energy buildings, right? Energy efficiency is first. That's the first piece. And I think a lot of people, when they talk about zero energy, they say, well, if I just stick a bunch of PV out there, I will solve the problem. Right? The number of floors has a big impact. Right? Remember our discussion about houses? Pretty low density, single story, right? As the number of stories goes up, the probability that I can get to zero energy goes way down. And after about 3 stories, it's really hard. Because what I'm doing is I'm going up, and I have less and less surface area to deal with. Now somebody's going to be really smart, raise their hand, and say, well, how come you just don't put it on the front of the building? Right? Well, what happens when the building next to it builds up? In reality, how much sun is really yours? That which hits on the surface of your building, basically the top surface. Right? Actually, officially, it's normal to the sun. Right? Okay. But it goes way down, and that adds challenge to the problem. Okay. So, yes?
I went to ask you this before, but now I really want to ask you. When
Okay.
you use the term residential,
Yes.
so ASHRAE has a term for residential, the codes have a term greater than 3 stories, a zillion units, whatever that is. And then the references you made here are primarily to 1 story, and now you just told us about 3 stories. So what kind of residential are you, in general speaking?
Good question. So when we talk residential, primarily it's the ASHRAE definition, 3 stories or less. It could be townhomes. It could be kind of 3-story apartment, although there's some complexities of how you move energy around, right? But in general, it's the good old suburbia single-family home. Okay? And that is the majority of the residential stock. It is not anything classified as residential, but really it's a commercial building from a fire egress point of view. Okay? You know, elevators,
Not high
things like
rise.
that. Not high-rise. Right? That's a commercial building in our world. Yes, sir.
When your floors go up, your surface to volume ratio is declining, which means that your skin losses are, for the volume contained is decreasing. How much of a benefit do you get? Well, when does that start to not become part of the solution, part of the problem? Because that has implications for the density of the community.
That's there's probably a whole thesis tied up in that question, right? So one of the interesting challenges are, and I've heard this is, are we better off with denser communities that are higher rise because you deal with the transportation problem, right? Or are we better off spread out so that we have a lot of roof area to generate PV? Right? Now, some of that depends on how you draw the boundary. Right? If you draw the boundary just around the building, it very obviously is what? Right? Spread it out. Right? If you start including transportation, then what? Now, you have to be very careful about transportation. And it's interesting, we'll talk about boundaries later. It's interesting how selective people are. And if you get nothing out of today, think about boundary. Got it? Right? All you're taking notes, boundary, boundary, boundary. Right? Because it's interesting, people get very selective with boundary. They're like, well, we want to include the commuting mileage of all of our occupants, right? What about all the stuff you've got to get to that building? Where's the food coming from? California? On what kind of vehicle? Right? Well, we're not going to worry about that. Okay? We'll just, people pick and choose what they want to include in that boundary. One of the things about Oberlin College, was, one of the big features of that building was they treat their own wastewater in the building. Now, there are issues with that, with codes,
That was an early problem.
right? And I still don't think they don't run it back into the potable system, right? I think they may run it back into the toilets. I'm not even sure they've got permission to do that. Either of you guys
They
know?
run out to the pond outside.
I know they run out to the pond, but then what do they do with it?
Just goes in the drain.
Yeah, I haven't paid much attention, but anyhow, 10% of the energy of that building goes into treating their own wastewater, right? What happens to the wastewater in this building? You don't know. Where does it go?
It goes into the sewer.
It goes into the sewer. Not my problem, right? Boundary, right? There is an energy impact for putting that water into that pipe, right? That, not gonna worry about that one. Right? So boundary is very important. As far as the whole skin piece, right? At some point what happens is if you build it too dense, your internal loads start to dominate the problem, right? That's a slightly different part of that same question. Sometimes it helps to spread it out. Sometimes it helps to bring it together. This afternoon we're going to talk about how we dealt with our data center needs, because that actually is one of our biggest internal loads in that piece of it. That sort of answer the question?
Yeah.
Okay. Kind of got on a couple of tangents there. So you have this vision, right? You want to build this zero energy building. It's kind of sitting in this cloud, right? Make you feel good?
Yep.
Feel good already today? So in order to do that, though, right, we can talk about, I want to build, right? I'm a client. I go to you and I say, I want to build a green, sustainable, low-energy, eco-friendly building. And what do you say?
You got money?
Money? No, I don't have any money. I might have a quarter. It won't get me back onto the thruway, though. Or it might get me onto the thruway, but not off the thruway.
Government employee.
Government employee. You know, I mean, people throw these terms out, and boy, it makes you feel good, right? Everybody wants a green building. And in reality, and we did a lot of the pilot stuff for our lead in the mid-90s, and DOE kind of helped seed some of that, right? And they've done a great job at marketing the term and putting it out there. But one of the challenges is, you know, so that's kind of the next piece. Well, we need a little definition on that. I want a LEED gold building, right? And people now have some idea what that means. They still mean, do you have the money, right? But a lot of people are doing that. Some jurisdictions kind of give this fast track permitting process if you come in and say that, right? But that really hasn't defined or solved all the problems, right? In fact, the game is now, who can come up with the least dollars per point, and which points do you go after first? I think I will put a bike rack out in front of a thruway rest stop. I just got a point. Right? Now, it is a cheap point, right? Is it sustainable? Is it green? Is it, I mean, pick whichever words you want to use, right? But that stuff happens all the time. And it's all because people figure out, are any of you students? You all were students. Students, right? The objective is what? To figure out how to get the A with the least amount of effort? You going to admit that or not?
Absolutely.
Right? Or maybe it's a C.
The economists would take that approach.
Boy, this is a tough crowd. I didn't even have to say that.
The developers will take that approach.
Oh, okay. Yeah.
Guaranteed.
But isn't that what happens? Is you put the rules in place, you put the test in place, and people will figure out how to get there for the least amount of effort, and that really is cost.
Unless you're a nonprofit who has a vision that wants to do better.
Oh, well, that's my vision slide, right? Yeah, but what happens is they usually ante up with money,
Yes.
right?
Buy it.
They buy it. Okay? They buy those points. Okay? That's an important thing to remember because that is where the industry is today. That's how we operate today. But I like goals that are a little more specific. Designability uses 30% less energy than ASHRAE 90.1. Pick your date, 2004, 2007, 2010. I don't care which one. But at least that now gives you a number. And at the end of the day, you can say, did you or didn't you meet the goal? If I put up a green, sustainable, low energy building, at the end of the day, did I meet the goal? That was your goal. So did I meet it?
That's your goal.
Absolutely.
No, only if it operates then.
Only.
No.
Yeah, but now you're talking about operation. That's an energy thing, right? But at least now I start to have some numbers. The problem with that is, and what I've observed is when we do 30% savings, what people do is they spend more time figuring out how to manipulate the base case than they do in figuring out how to make the building low energy. I much prefer, I mean, it could be based on something like 30%, but by the time you get ready for the start of the day, designability uses less than 25,000 BTUs per square foot. Okay, that's a number. It can come out of the simulation. We're going to talk about later how we're going to validate and substantiate that. Okay. The nice thing about designing a zero energy building is that that is also a number. It's a very concrete, determined number. And that is one reason it has part of the vision, but it also is a very specific number that you have to meet at the end of the day.
Yeah, but that's a definitional problem.
Well, remember, one of the things I talked about was our role was to figure out what that definition was going to start looking at, right? All of these are about influencing purchasing decisions. Okay? So, how are we going to influence the decision? I've got this goal. Now, if I was going to build an energy efficient, grid independent house, right? And I was going to bang all the nails, and I was going to do the design, would I succeed?
I think it would.
Probably would, right?
Use Adobe, not wood.
Yeah, well, we've got a guy at the office that set out to do that. He built a lot that was, well, he found a lot. It was dirt cheap. It was a mile from the utility grid line. And he started stacking concrete block and put 6 inches of ethos on the outside of it. And passive solar, 1 kilowatt of PV, and he was good to go. Right? He had the vision. He made all the purchasing decisions. He made all the labor decisions. Right? Very easy to achieve the goal. But what happens is that more people get involved. Right? And it works out pretty well. Remember the whole discussion about small buildings? I mean, if you've got small teams and small number of decision makers, they're all pretty connected to that goal. And it works out pretty well. Because they can all capture that vision. More or less. Every now and then you get people that are kind of outside the box, right? We did a building before we did this goal-based procurement that I'll talk about later, right? And one of the things we put in the specs was, thou shalt use all T8 lamps with a certain lighting power density, right? Problem solved in the lighting, right? I walked into the building one day, right? Almost done with construction. And I hit the elevator button, and the doors open. And there are 16 MR16s looking at me. I could get a tan in there. Oh, we're sorry, sir, but the elevator isn't part of the lighting system. Right? I walked down the hallway to some of the lab fume hoods, and they all had T12 bulbs in them. I was like, what? And we had a lot of fume hoods in this particular building. I was like, what's up with that? Oh no, the fume hoods are not part of the lighting system. Right? There are people that were completely disconnected from the decision-making process that were making lighting decisions. Right? You say, well, it's not a big deal. Right? Well, start adding them up. And suddenly it is a big deal. Not only is it a big deal, we now have to inventory MR16s. Can you picture the National Lab wanting to, inventory MR16s and T12 lamps? So part of it is you got to keep everybody in the same circle. You got to be able to motivate all those people. Now, build a building like this one. How many people were involved in building this building, designing this building, making decisions on this building? Thousands.
More than that.
University campus. Tens of thousands. somebody is not going to be engaged in the process. And part of what you need to do is engage and line up all these people into that process. Okay, so, zero, right? Very easy, very clean. We're getting one head nod over here. Not true. And so we set out to say, well, what kinds of things are out there for zero, and how do we put that together? So there's some guiding principles that we came up. You know, conceptually, that buildings can meet all their energy needs from renewable sources. That sounds pretty good. Sounds fairly easy. Concentrate on the demand side. Okay, I'm going to show a little bit later that some of it's a cost issue. Then the supply side. The most common definitions today, you do use the grid for balance. Right? Talk a little bit about maybe some issues with doing that. If I build a grid-independent house, my friend Otto, who built his house up in the mountains of Colorado, it's grid-independent. Is it a zero-energy building? What do you think?
Zero energy site.
Depends
Depends. Depends on what?
where it's at and embodied energy materials.
Oh, now, whoa, embodied energy and all this other stuff. We haven't even gone there yet, right? That's a whole different part of the dialogue, right? Let's just talk about the